Kubernetes is defined as an open-source platform that is used for container orchestration. This scalable and portable solution automates several processes during containerized applications deployment, scaling, and management. In this video, let's understand the working, architecture, and importance of Kubernetes. How does Kubernetes work? Kubernetes is vendor-agnostic and compatible with most leading server and cloud solutions, including Azure Container Service, Amazon EC2, and IBM software. It also works with bare metal configurations using CoreOS and similar solutions, as well as vSphere, Docker, libvirt and Linux kernel-based virtual machines. But what exactly does Kubernetes do? Managing individual containers becomes an uphill task as an organization's container infrastructure scales up. Kubernetes gives containers visibility using either DNS or IP addresses. Additionally, Kubernetes groups together the containers that run the same application. The containers replicate each other's functionality and balance the load of incoming requests among themselves. The load in high-traffic containers is balanced, and network traffic is distributed to ensure a stable deployment. Kubernetes operates as a cluster in several nodes, making applications more robust and automates static and dynamic scaling. Simply put, Kubernetes can automate rollouts and rollbacks. To understand how Kubernetes works, let's deep dive into the Kubernetes architecture and take a look at the specific components. 1. Pod. Pods are simply groups of containers, the smallest architectural unit managed by Kubernetes. Each pod has one IP address shared by all its containers. Resources such as storage and RAM are shared by all the containers in the same pod, allowing them to operate as one application. 2. Deployment. Deployments allow users to specify the scale at which the application needs to operate. Users must define their preferences for pod replication on the Kubernetes nodes. 3. Service. A Kubernetes service is an abstraction over the pods. This component is the interface that application users primarily engage with. Even though replaced pods might be assigned new names and IP addresses internally, services ensure that these details remain the same to the network at large. 4. Node. Nodes are the physical or virtualized machines that execute the assigned task. They are responsible for running and managing pods. When the container infrastructure operates on a large scale, users can assign tasks to nodes, which are then delegated to pods with the available bandwidth. 5. Control plane. Administrators and users access Kubernetes through the control plane, which allows them to manage nodes effectively. This component is responsible for controlling the interactions between Kubernetes and applications. Operations are assigned to the control plane either by linking to the machine and executing command line scripts or via HTTP calls. 6. Cluster. Clusters contain Kubernetes software nodes and access the same memory and computing resources. Cloud infrastructures such as Google Cloud and AWS automate the management of clusters. Users only need to provide the physical specs and the number of nodes. Kubernetes is increasingly being adopted by enterprises looking to enhance their application administration capabilities. Gartner predicts that by 2022 more than 75% of global organizations will be running containerized applications in production, a huge jump from the mere 30% in 2019. That's why companies need to understand why Kubernetes matters today and what are its benefits. Here are 5 key benefits of Kubernetes that companies need to be aware of. 1. Improves development efficiency. Kubernetes simplifies development, thus making deployment and release processes more efficient. For instance, this framework allows engineers to undertake container integration and enables administrators to access storage resources from various vendors seamlessly. 2. Minimizes cost inefficiencies. Kubernetes automates the modulation of resource allocation processes according to the actual needs of applications. Intelligent container management through Kubernetes enables enterprises to minimize ecosystem management costs and boost scalability across operational environments. 3. Enhances availability and scalability. Organizations can scale up the resource allocation for specific components of their applications by using Kubernetes. This allows for flexible, need-based scalability and facilitates dynamic peak management. 4. Supports multi-cloud environments. Containerization backed by Kubernetes allows users to leverage multi-cloud and hybrid cloud environments to their total capacity. With Kubernetes, applications can operate in all leading public and private cloud environments without suffering from any loss of performance. 5. Simplifies cloud migration. Kubernetes is a helpful solution for simplifying and accelerating the migration process. Thank you for watching this video. Tell us in the comments below if this helped you better understand Kubernetes and its benefits. Keep watching this space for more tech information. Check out the article link in the description box. To stay updated with the latest in technology, visit www.spiceworks.com.